On February 14th, in 1876, a 41-year-old Elisha Gray walked into the U.S. Patent Office with a patent application for a device that was capable of sending vocal sounds across telephone lines. Western Union was looking for someone to create more efficient telegraphs using multiplex telegraphy. The problem? That very morning, in 1876, a 29-year-old speech therapist named Alexander Graham Bell had filed a patent for exactly the same thing. Bell ended up holding the patent, and Western Union, having previously bought Gray's patent rights, had turned down an offer Alexander Graham Bell made to them to buy the patent off of him. They then offered a $1 million reward to anyone who was able to prove that Elisha Gray had the official rights to that patent. The reward was never claimed. Two people in very different lines of work, in very different regions, had developed precisely the same product at precisely the same time. The cause? They both had the resources to make it happen, and they were both driven by Western Union's call for someone to invent that technology. Similar environmental conditions led them both down identical paths. What do bats have in common with birds? What about whales? Cats? Bears? Convergent evolution is an ecological phenomenon where two species, completely unrelated through phylogeny or shared ancestry, develop a similar trait. Let's talk about bats. Bats are really weird and unique creatures. They fly like birds, but they're mammals. They can see in the dark like cats. They use sound as a navigation tool like whales, and some species even hibernate, like bears. So why does convergent evolution happen? Well, selective pressures are the environmental factors that shape the phenotype or visible genetic expression of a certain species. These selective pressures require organisms to develop mechanisms that allow them to better tolerate those conditions. A simpler way to look at this is that function dictates form. Many of the species who develop similar traits happen to be in similar resource scarcity situations and are seeking the same benefit as another species from a narrow list of opportunities. There are many examples of this across the living domain, but let's focus on some of the most fun. We'll start with the octopus. The octopus has strange color-changing skin with a trio of cells responsible for this outstanding ability. Chromatophores are specialized cells responsible for the actual shift in pigment color. Iridophores are reflective cells and can help reflect the coloration both of the chromatophores as well as natural colors from the creature's surrounding. Finally, octopi have a cell type called a leukocyte. These cells have a white pigment and can be surfaced to create a more dynamic camouflage appearance on the skin of the octopus. Other species like the chameleon differ here. The chameleon does not have leukocytes, and instead has yellow pigment zelanophores and brown pigment melanophores. Other species which camouflage developed similar phenotypes with different underlying genotypic mechanisms. There is also convergent evolution in the plant kingdom. Predatory plants independently created mechanisms for trapping and digesting prey, all without having a conversation first to decide the best way to get it done. They bait the prey, ensnare the prey, then digest the prey. They all do this in slightly different ways, both chemically and mechanically, but nevertheless independently developed the ability to trap and consume those sorry fools looking for a sweet treat. Some honorable mentions for this video include the antifreeze blood developed independently by fish in both the North and South Poles, permitting survival in some cases in below freezing water. Also, the development of the hypodermic needle as a defense mechanism developed out of many organisms separately, including the platypus, snakes, spiders, and a myriad of other species. In conclusion, convergent evolution is a fascinating way to describe isolated parties responding the same way to similar environmental pressure. It tells us, just like every other part of biology, that all of us critters on Earth are not so dissimilar. We always have more in common than we realize. Thank you for watching today. I hope you learned something. I'll see you in the next one.